let us continue on the course on biostatistics and design of experiments. We will continue on ANOVA. ANOVA is nothing but analysis of variance. It is extremely powerful. We are going to spend a lot of time on this ANOVA and we will do many problems. Like I said, there are something called one-way ANOVA, two-way ANOVA, three-way ANOVA and so on, and many of the software packages cannot really do such large different ways of ANOVA, but we are going to do it through fundamental approach. So, in the ANOVA we are looking at variances and then we use F-test. So, what is the F? Between group variance divided by within group variance. Okay. So, within group variance we always call it error. So, between group is the effect of each group or each treatment or each drug or each operator or each instrument and so on. So, within group is when I do many times I will have some variation. I am looking at what is the error. So, when we calculate this F, then that is called the F statistic, and we compare it with the table and see whether the F value which we calculate is less than the table value. Okay. If it is less, then we will not reject the null hypothesis. If it is more, then we will reject the null hypothesis. So, here generally the null hypothesis will be variance from 1 is equal to variance of 2 equal to variance of 3, that is the null hypothesis, and the alternate will be not equal to. Okay. So, let us carry on. So, what do? We calculate a lot of sum of squares. If you remember in the previous case, we calculated total sum of squares, then we calculated the between groups or between sample sum of squares, then we calculated within sum of squares, and after that we made an ANOVA table, and then we calculated the F ratio. So, let us look at another problem. Okay. Now, let us look at this problem. Average voice pitch for male and female participants. So, we have 3 data from male and 3 data from female. It is a small data. So, obviously the degrees of freedom is less. So, the F from the table will be very high. For example, in this particular case, if you look at the 2 and 2 sort of thing, the F values will be very high. Let me show you the table. As you can see, the F values are very high, especially when you have less number of degrees of freedom, and as you go with higher more and more degrees of freedom, you will get smaller F. So, always remember that it is better to have a large data set, but okay, we have a problem here. The average voice pitch of 3 male is collected and the average voice pitch of 3 female are collected. Okay, there is a lot of variation, as you can see, 87, 150, 120, there could be variation because of their health condition or because of the food they had consumed slightly before, and weather condition and so on actually. So, let us not bother about it. So, there could be physiological as well as psychological reasons, that is why you find such large difference. So, these are called within group variance or error variance, and when we compare these two we call between group variance. So, obviously the F value we calculate between group variance divided by within group variance, and we have to have a sufficiently large F, much larger than the table, then only we can say statistically there is a significant difference between the pitch of male vis-a-vis the pitch of female. As you can see, there is the within group variance or error variance is going to be large, because you see 87 and 150, whereas here it is not much, but here it is huge. Here also it is huge, 140 and 210. So, the error variance or within group variance is going to be large unless we have sufficiently large difference between groups. Our F ratios will not be sufficiently large. Okay, last time I taught you how to look at various sum of squares. There are 3 important sum of squares: total sum of squares, between group sum of squares, and within group sum of squares. Now, for total sum of squares, the degrees of freedom is in this particular case 6 minus 1. Between group we have 2 groups, so the degrees of freedom is 1. Okay. So, the total sum of squares is 6 minus 1 5, between groups is 1. So, for the error sum of squares or within group sum of squares, it will be 5 minus 1 4, okay, degrees of freedom. Okay, so, we calculate total sum of squares, then we calculate between sum of squares, and then we calculate within sum of squares, and then we make the ANOVA table. So, let me again show you. there is something called total sum of squares. So, total sum of squares, how do you calculate? X is any value minus x double bar. What does x double bar mean? X double bar is overall mean of the entire data. So, because you will get a mean for the male pitch, you will get a mean for the female pitch, that will be called x bar, whereas when you take the mean of those two means, that will be called x double bar. Okay. So, the total sum of squares is equal to x minus x double bar square. That means you calculate the overall mean of the entire data set, and then you subtract each of these data, 6 points, there are 6 data points, subtract, square it, that will give you the total sum of squares, and the degrees of freedom is 5 because there are 6 data points, understand. Now, between samples we have 2 samples, one is the male, other is the female. Okay. So, there is an average for male, okay, then there is an average for female, agreed. So, you subtract that with the overall mean, square it, and then you multiply by number of data points in that. For example, there are 3 male, so we multiply by 3. So, for male what do? We take the male average, subtract from the overall average, square it, multiply by 3, okay, plus you take the female average, subtract it from the overall average, square it, and then multiply by 3. Okay. So, that is how we calculate between some sample sum of squares. Now, within sample, now this gives you the error. Okay. Within sample is the male average, so subtract each one of the male terms, square it, add it up, that is 3 times you do that. Then you take the female average, subtract from each one of the female data, square it up and sum it up. Okay. So, we get within sample sum of squares. So, as I said, the degrees of freedom for total is 6 data points, minus 1 is 5. For between samples we have male and female 2, minus 1 is 1. So, 5 minus 1 is 4, that will be the within sample sum of squares. You can also cross check, total sum of squares will be between between sample sum of squares plus within sample sum of squares. Okay. So, the null hypothesis will be sigma 1 square is equal to sigma 2 square, that means variance for male is equal to variance for female, and the alternate will be sigma 1 square is not equal to sigma 2 square. Okay. Once you do this calculation, we need to prepare this something called the ANOVA table, that is very important, that gives you the sort of a summary of all our calculations. So, between sum of squares, okay, between sum of squares, as I said, you do it like this, okay, and degrees of freedom will be in this case 1, then within sum of squares you do it like this, okay, and then total sum of squares you do it like this. Okay. So, in this particular case the degrees of freedom will be 5. So, 1, 5 minus 1 will give you n2. Okay. Now, if I want to calculate my mean, so what do I do? BSS divided by n1 and then WSS divided by n2 will give you the mean for these two. Now, this is error, this is variance between, so F1 by F2 will give me the F ratio. Then from the table, F table for n1 and n2 degrees of freedom, I see whether the F calculated is greater than F table or F calculated is less than. So, if calculated less, obviously there is no reason for you to reject the null hypothesis. If F calculated is greater, then there is a reason for you to reject the null hypothesis. Okay. So, let us look at this problem. 150, 87, 120, that is the male pitch, and 210, 180, 140 is the female pitch. So, I add all these 3, divide by 3, I will get the average. This is the male average. Similarly, add all these 3 divided by 3, this is female average. If you take an average of 119 and 176, I will get the global average, that is the overall average. Okay. Now, how do you calculate total sum of squares? You remember this equation? So, you take each one of the data points, subtract from the global average, square it up and keep on adding. Okay. So, I take 150 minus 147.8, subtract, square, 87 minus 147.8 square, 120 minus 147.8 square, 210 minus 147.8 square, 180 minus 147.8 square, 140 minus 147.8 square. Add up all of that, that will give me 9440. understand, this gives you the total sum of squares. Okay. Now I want to calculate between sum of squares. How do you calculate between sum of squares? If you remember, you take each of the average, subtract it from the global average, square it, and then multiply by the number of terms there. Okay. So in this particular case, what do I do? 119 minus 147.8, square it, multiply by 3, because there are 3 data points. 176.6 minus 147.8, square it, multiply by 3. So you will get this. Now you add both these through, that will come to 4988. So this gives you the between sample sum of squares. Degrees of freedom will be 1. For TSS, degrees of freedom will be 5. Okay. How do you do within sum of squares? So you know the average, you know each value. So 150 minus 119 square, 87 minus 119 square, 120 minus 119 square, 210 minus 176.6, because this is for the female, 210 minus 176.6 square, 180 minus 176.6 square, 140 minus 176.6 square. So if you add up all these, it comes to 4452 point. This is called within. This is an indication of the error. Okay, if you add between and within, you should get the total. No, can you see that? So we have 8 plus 2 10, 5 plus 3 13 plus 1 14, 4 plus 9 13 plus 1 14, 4 plus 4 plus 1 9 4 4 0. That is a cross check. Okay, so between we take it as 4988, within we take it as 452, and then total is 9440. And then degrees of freedom, like I said, there are male and female. So 1 degree of freedom for total 6 data points, so 5 degrees of freedom. So within will come to 5 minus 1 is 4. Now mean sum of squares 4988 divided by 1, 4452 divided by 4, that gives you this. Now the F ratio is between divided by within. Within is an indication of error. So it comes out to be 4.481. Okay, it comes out to be 4.481. Now if you go to table, okay, if you go to p is equal to 0.5, what do you take? You take 1 comma 4 degrees of freedom. So 1 comma 4 comes to 7.71. So 7.71 is your table value. Calculated is 4.48 at 95% confidence. There is no reason for you to reject the null hypothesis. Cannot reject the null hypothesis at 1 comma 4 degrees of freedom at p is equal to 0.05. Understand how to do this? So it is not very difficult. It looks tricky, but it is not difficult. So we get the total sum of squares, we get the between sum of squares, and then we get the within sum of squares. You can always subtract total minus between to get this also, just like degrees of freedom, you subtract total minus between to get this. So no problem. So you can avoid these set of calculation, but I am teaching you how to do that. That is very important. Okay. So I am teaching you how to do that, and so we get between, and then we get total, and then we get mean sum of squares by dividing by the degrees of freedom, and then F ratio is given by error will come in the denominator, and between the groups will come, or between the groups, or between the gender male and female will come on the top. So we get F ratio of 4.48, and table gives you at 1 comma 4 degrees of freedom 7.71. So there is no reason for you to reject the null hypothesis. Understood? So it is not a difficult problem to do. Okay. Excel also can do the same thing. There are different ways. Okay. There are different ways by which we can do it through Excel. There is a command called Ttest, where you give array 1, array 2, and it calculates the F ratio, okay, and then it tells you. Actually it does not do it through ANOVA, but it does it through Ttest. Ttest is nothing but ratios of the two variances, okay. And then of course you remember this Ttest command, it gives you the probability given the ratio for 2 degrees of freedom, and F inverse command when you give the probability, it will calculate the F value for the 2 degrees of freedom. This is exactly like table. So let us look at it also, right, how to go about doing this problem using Excel. Okay, so Excel, you go to Excel, say this control, okay, so we say f test so it gives you the probability. So returns the two tail probability that the variance in array 1 are not significantly different. Okay. So it gives you the probability, and as you can see the probability is 0.89. So there is no reason for you to reject the null hypothesis. Now we can do it by Ttest also, so but in the Ttest you are giving the ratio. Okay. In this particular problem the ratio is 4.48. Okay. 4.48 is what you have to give, and the degrees of freedom for each one of them. Okay. So Ftest 4.48 1 comma 4, oh sorry, Fdist 4.48 1 comma 4 0.10. So for the ratio it gives you some probability 0.1, so we cannot. Given the probability it can also calculate is exactly like the table using the finf command. Okay. So 0.05 1 comma 4, so 7.7. So you have to reach a ratio of 7.7, whereas the ratio is calculated is 4.48 as I shown here. Okay. So there is no reason for you to reject the null hypothesis. Okay. So we can do it using Excel also, but Excel does not do it through ANOVA. Excel does it just by the Ftest. Ftest is nothing but it calculates the two tail probability for array 1 and array 2. Okay. So it does not look at the error sum of squares, it does not look at between sum of squares, but it just comparing two variances of two data sets and doing the calculation. Okay. So if I have 3 data sets, I can't use the Ftest, a command that is available in Excel. So I have to do it through ANOVA. I am going to show you some problems there. Okay. Only if you have 2 data sets we can do ratio of 1 divided by the ratio of 2, but unfortunately if there are more than that then it is not possible. Now we can also do it by 2 sample t-test, right. So we have one data set, another data set, so can we do it by 2 sample t-test. Okay. So you all know Ttest. Okay. So data set 1 comma the data set 2 comma, so it is a 1 tail or 2 tail, so no difference and all that. Okay. So we can say 1 tail distribution comma, so unequal variance. Okay. So we can say 3 comma 3, so it is greater than 0.05. So there is no reason to reject the null hypothesis. So let us do, I did unequal variance, let me try equal variance also. One sample t-test, equal variance also, let me see. It's okay. So it's still slightly greater than, so if you do t-test you may start wondering maybe it's very close border because 0.05 for a 1 sample t-test, but the Ftest shows a very big difference, right. Ftest shows a lot difference. The calculated F is 4.48, whereas you expect it to be larger than 7.70 for a statistically significant difference. So your variance of the within is very large. So obviously because of that we are not able to differentiate between the 2 data sets, that is obvious. Okay. The variances are very large. Okay. Because of the variances are very large you are not able to. If you improve on the variances for a, this is coming out for a 2 tail test actually, whereas the previous one is for 1 tail test, because here as you can see I had put 1 here. whereas here I put 2. Okay, so variances are large, that is why we are not able to differentiate between the 2 data sets, that is one thing, because the error variance comes in the denominator, and so the f value comes out to be small, that is why it is not significantly larger than the table f actually. So, you need to remember this, your variances are extremely large. Look at this 87, 150, similarly 140, 210. So, almost 70 difference in the pitch, okay, that means about 30% difference. So, when you collect data sets, remember you need to collect a large number of data sets, that is one thing, and try to have more consistent data. Otherwise, if you are going to have large variations, you will not able to see between group variations at all. You know, these error variance may take over, and you could be in real problem of not able to see differences in the between group. Okay. So, let us recall. In this particular problem, we found out 3 types of sum of squares. Okay, 3 types of sum of squares. One is called the total sum of squares, and that is obtained by subtracting each one of the data point with the global average. How do you get the global average? Average for male, average for female, and then take the average of the average, that is the global male average, that is total sum of squares, straightforward. Now, there is something called between sample sum of squares. So, for each sample you have an average. So, you see the difference of each one of these. Okay. So, you have say you have taken an average, okay. So, there is a global average. So, this 119 is different from 147. So, you subtract this, square it up, this has happened because of 3 data point, multiply by 3. Now, you subtract the female average in 147, square it up, multiply by 3. You add all these, that will give you between samples. If you want within samples, 119 minus 150 square, 87 minus 119 square, 120 minus 119 square, 210 minus 176 square, 180 minus 176 square, 140 minus 176 square, you add up, that will give you within. Within is an indication of the error, okay, that comes out here. Between is the effect of the group or treatment or drugs or operators or patients, whatever it is. Okay. Then the total, one important point you need to remember is if you add up these two, you should get the total, and the overall degrees of freedom 6 data points minus 1 5, between has a degrees of freedom of 1 because we are talking about 2 genders, no, male female. So, 1, so within will come to be 5 minus 1 is 4. One important point you need to keep in mind is this error or within should have sufficiently large degrees of freedom, that is very, very important. So, do not have a very small number here, then you are not able to really quantify the extent of error in this. Okay, once you get the mean sum of squares, you divide the between by error, okay, to get the f value, then you compare it with the table f value. Okay. So, that is how you do this problem. So, it is not very difficult. So, main takeaway from this is because we have a small data set, we are not able to really decipher, although you see the gender average wise the female has a higher pitch than the male, we are not able to say there is a statistically significant difference because of the variance here. Okay. So, variance, I talked in the first or second class that variance is more important than mean, which is coming out very clearly here. We see there is a very large difference actually 119 and 176, but statistically we are saying there is no statistically significant difference. Why? Because of this large variance, and we need to keep that point in mind, that variance is very, very important, that will play more important in statistically identifying significant differences or not finding significant differences rather than the mean. And ANOVA is completely based on variances and Ttest is completely based on variances. So, we need to keep that particular point in mind. Okay. So, let us continue more on this ANOVA problem in the next class also, because so that I would like you to have good confidence. Now, Ttest which is available in Excel can just do a Ttest alone, that means it will take a ratio of 2 data sets. Suppose I have 3 data sets Ftest, this function cannot do anything. We need to go through ANOVA, and there are commercial softwares which can do that. And then finv I talked about is exactly like the F table, given the degrees of freedom, given the p, that is 0.05, it will tell you what will be the f value. Fdist tells you the other way, and it gives you the probability given the f ratio. Okay. So, the Excel functions cannot really do too much of ANOVA at all in this. Okay. Now, of course, there are different other ways of doing that. If in order to get an ANOVA table, we can use a regression relationship to get the ANOVA. We will look at it much later when we go around. Okay. So, that is the problem with the Ftest. Whereas, if you now of course, you can use this 2 sample Ttest also to do it, but then the 2 sample Ttest has limitations. Suppose if I had between groups male, female, infant, then 2 sample Ttest means I have to take 2 sets of samples one at a time and perform this type of Ttest, which is not very comfortable. And also Ttest looks at means, whereas Ftest looks at variance also. Okay. Okay, we will continue with the more problems as we go along, as I said, in the course of the next class as well. Thank you very much for your time.